Thanks everyone for joining this webinar. It is our pleasure to present this to all of you. So my name is Alex. I'm a product manager in the workshop, and I have my friend and colleague Miguel Yepes here next to me.
Hey guys, this is Miguel, software engineer here in the workshop.
So we've got this topic now today, device tracking in practice, how we went from idea to production. Let's share the agenda first. So what we would like to do with you today is, first of all, we'll mention what exactly we do in the workshop, what is device tracking for us, what is fraud screening for e-commerce in general and in our context, duplicate account concept, what we found when we went live, and things about more information about performance. And at the end, yes, we'll have some time dedicated for questions and answers. So let's kick it off. So what do we do in the workshop? So in the workshop, what we do is, of course, we build software, we provide IT intelligence, and we do analytics. What our clients do is, one second, okay. So our clients, they have customers, of course, that make online purchases on our clients' websites. They do it from all over the world, and this is happening 24/7 non-stop. Of course, you know that anywhere where you can pay with a credit card, there's a very high risk of fraud, and fraud is expensive. And our customers would like to avoid fraud in their systems. Some general information about how much fraud costs to the businesses worldwide. You can see here that in the UK alone, it costs around 200 billion Great British pounds a year. And card fraud hits more and more card holders on a yearly basis. Nearly a third of consumers have experienced card fraud in the past 5 years. So really, online fraud costs billions of dollars to businesses worldwide, and our clients would like to minimize the risks of fraud to their businesses. Here's what we do to mitigate that risk. We've got several anti-fraud tools that we use, such as IP blacklisting. We're able to blacklist certain IP addresses or ranges. We have credit card blacklisting. We do KYC verification for our customers. And we are also able to do geolocation validation. Now, we wanted to have the ability to tag customers and find connections between them. So the question then was, how exactly can we identify the customer? So after some research, we identified the need to track the customer's device. And here I give the word to Miguel to talk about device tracking.
Yes, we felt the need about tracking the customer's device, but what's a device? For most of our cases, there are the customer accessing to our different apps through a browser. The browser doesn't contain a device at all. I mean, there is not possibility of access to the real customer device because of security reasons. The modern browser don't implement it. So after some research, we ended with the different approaches to get information about the browsers. One of them is by tagging. We wanted to tag a browser, and for it, there is a mechanism like setting values on it. Common ways of adding this value is based on storing data in their site. Cases like IndexedDB, local storage, web SQL database, or the quite common HTTP cookie. But also we wanted to use another more, that is HSPS, protocol implemented by the browser that makes a redirection from HTTP to HTTPS, but basically setting a flag into this browser. Collecting all this data into a single point, we ended calling this the super cookie value. what other mechanisms can we get or face to get the information about the browser? Quite common is the fingerprinting. And what's a fingerprinting? The browsers have a different collection of properties. We can read these properties, and by reading these properties, we can make a pretty unique value. These properties can maybe like user agent, pixel radio, the resolution, donut track flag, the plugins the customer has installed into his browser, or even the GIS fonts. And what if from these properties we create a kind of array and hash it well? That's for us the fingerprint. Then, after some more research and talking to our fraud agents, we consider interesting also adding a couple more points, like the browser language and browser time zone. With this, we have the ability to track in a pretty unique way a browser. And this is the browser itself. Then, next step will be modeling. How can we model it? There are two entities. One of them is the customer, the other one is the device. So we can normalize this small model and into a table like this. A table where there is these columns with a customer ID, the super cookie, fingerprint, browser language, and browser time zone properties. And then let's move to our use cases, starting with an example, getting the device, getting customers with the same device. How can we run a query for it? Just running a join with the same table and comparing data, joining the customer ID in these cases, and we need to scan the table twice. Going further, what if we want to get the customers that are connected to a device from the previous customers? Well, things are becoming more complex, and this is the concept of two hops. In here, this is an example of how should it be, where we need to join 3 times the table and return the results. But this is just the beginning. If we want to apply criteria like get 3 hops, or from these 3 hops, getting credit cards in common, or even identify what are the common points that are shared by the devices from the previous results. Well, these are real cases that are becoming more and more complex. Imagine with the time trying to handling or maintaining an application like this. Sadly, it's like quite complex. And well, let's try to do the same exercise using a graph model. In a graph model, these are our entities, the 4 that are from the device and the customer here. And here we go, relationships. This is our natural model that can actually represent the reality. Because of the performance and having a way of improve the way we are querying the graph, we decided to create the entity and device that is connected to these 4 points, and also the customer linked to this device. Running the previous use cases, there you are, the first result, customers with same device using the Cypher. Cypher, well, you probably know, is the query language implemented by Neo4j to query the graph database. And we just run a match from a customer 1 to a customer 2 through an intermediate node of type device using a relationship of type use device, returning the results. We can simplify this. I will use this pattern from now on to make things a bit easier to understand, but mainly is just from a customer 1 to a customer 2, there is 2 relationships of type use device without taking care about this intermediate node device. So this is the result of this question. Moving forward, 3 hops. We just need to increase the number of relationships between them, returning them. What if we want to get the credit cards that are in common? From the previous results, we add an additional clause that is matched from the customer 1 customer two through that are sharing a credit card, another type of credit card, returning this credit card. Well, you can see how things becomes easier, more understandable, and easier to maintain using this cipher. And once we have the tool to proceed to running queries, I will tell Alex to continue with this, explaining us how we run front screening on e-commerce. Alex?
Thank you, Miguel. So we talked about how to model and how to query. Let's actually see how we use all of this in production for our systems. So fraud screening for e-commerce. What happens, generally speaking, is we've got, I don't know if you see my pointer, but we've got one new customer that is coming to make a purchase with, let's say, a credit card through this device, and he's connected to another existing customer that was tagged as fraudulent. Now, when we talk about fraud and fraudulent customers, we should mention that in our system, customers can be tagged as fraudulent. So what we do is we either deny or allow a transaction based on the result of this fraud evaluation. Here's another example where we can run queries and extend with one more hop. So in that example, we've got one new customer coming on our website to make a purchase. He is connected through a credit card or through a device to an existing customer. That existing customer, though, is connected through some other credit card, some other device, or even some other data point to another existing customer that has already been flagged as fraudulent. And considering this, that we could use the data we've already stored, what we realized is that we can rely on hard connections because the result of the evaluation is always the same. So this is one of the cases where we apply this pattern, duplicate account or duplicate accounts. So whenever a customer registers on one of these websites, we obviously collect various pieces of information for them. Things like their device information, date of birth, name, zip, postal code, phone number, email address. Now, once we already have this for our customers, let me show you a real example from our Neo4j production database. So here we've got one customer that has some credit cards. We've got his date of birth here. We've got several devices for him. We've got his phone, email, IP address. This is how it looks like in the Neo4j browser. So whenever we have a customer registered and we already have stored all this information for them, what we could do is we could see the other customers that share some or all of this type of information. In this example, we've got a second customer that shares the same device, shares the same date of birth, and same email address. Here's a real example from production. We've got two customers, the blue notes, that share the same name, share the same date of birth, same postal code, and same phone number. So for us, we consider these two entities, these two accounts, as duplicate accounts. Basically, they are the same identity, same person. What we would like to do is treat them the very same way. What we do in the background is we create this relationship type between the two customers called duplicate. And here's how it looks again from this snapshot from Neo4j in production. We've got the same customers, and not only that they share the name, date of birth, postal code, and phone, but since we detected they share so many things, we created this duplicate account relationship type. Here's another example where we see 3 customers in that case. They share the same date of birth, they share the same email address, share the same name. One of them has several devices, several credit cards, and you can see the duplicate account relationship between the 3 of them. So for our system, we consider all these 3 accounts as the same identity. Okay, so how can we use this in real life? So this is what we were doing initially. So we were using only the device information and the credit card information from the transaction. So we have this new customer coming to make this purchase, and we are doing the evaluation only using this data. Now what we could do is extend that and use the data that's already there in the database, especially the duplicate account data. So in that particular scenario, we've got this new customer that is connected to an existing customer that is connected as a duplicate to this 3rd customer that has already been flagged as fraudulent. In that case, our system is able to automatically allow or deny the transaction based on the configuration of the system. And now what we could actually do is extend this to with one more hop. So here you see that this 2nd customer is connected to a 3rd customer by either device or credit card or something else that we can consider important. And even more, that this 3rd customer has a duplicate account that has been flagged as fraudulent. This is another interesting example from production where we have 6 groups of duplicate accounts connected between each other through 11 devices and 18 credit cards. There's definitely something suspicious going on here. Miguel?
Yes, after having this idea, modeling of this data, we went to prod, applying these criteria or using duplicates, extending it for more than one hop, and we actually realized that we deliver a monster, and I will explain you. This is what we were expecting. There are this screening we are doing here through these initial nodes, traversing to the final tax player that is a fraudulent one, and there what we found is there are some nodes where there were a lot of connections between them. Not only that, from these highly connected nodes, there were more intermediate nodes connecting to a bunch of customers, which make things really, really hard. Some examples that's easy to understand are these date of birth or the postal code. The customers that are sharing these nodes are highly connected. We started calling them dense nodes. Going to a basic example of one of the queries we were running, we can see just retrieving relationships between these 2 customers. What if there are millions of customers, and what if there are a lot of transactions per second? Imagine with this highly connected node, it was going to be huge, and actually it was. This is what I mean regarding the monster we deliver. We were literally killing the Neo4j cluster. So after some investigation, we decided to contact the Neo4j guys, and they friendly help us by coming in place a consultant and starting our work again. So after several days profiling the data, analyzing the distribution of this data, we ended with the solution that we needed to use the traversal API. And why is this? Mainly the production and distribution of the data you never know. We can run queries with random data that is generated, but then on prop, things are pretty different. So what do? We started using this traversal, and with traversal you can define several things like navigating and levels of depth, navigating through specific relationships, applying custom criteria like stop traversing on a fraudulent customers. If you have a defined evidence of a fraudulent customer, it's not needed to continue traversing, or ignore specific path, or database is highly populated and very rich regarding type of data and relationships. We just ignore the data we want depending on the case. And also applying criteria for smart traversing. In example, identify low dense nodes where we can start the query or running several iterations instead of all at once. This is pretty interesting because at this point we can get data in several iterations using the output of one iteration into as an input of the other. And what can we have there is a distributed system where the filtering is applied after the query. This was really advantageous for us. And here, this is a kind of summary of one of the queries we are using. As you can see here, this is getting the traversal description from GraphDB and defining the uniqueness criteria, identifying where to continue traversing or where to end, finally defining the depth and traversing through a list of initial nodes, the ones that I mentioned before that were low dense or less dense than the other. And after implementing this solution, we went to prod. Of course, the performance improved drastically. And here you have a snapshot of queries we are running from 2-3 days ago. And if before we were having times about 15-20 seconds, at the moment in just a few milliseconds, this is really acceptable because we are talking about online transactions, and the delay is really important. And not only about timing, also the performance. The chain cluster is now really relaxed, let's say that way. And so finally, for ending this presentation, I would like to show you a summary about these different use cases and a summary of the architectural implementation we have. So a customer on access, we generate the device in a synchronous way. We are indexing the device information into the U4J cluster. For it, we are using the indexers extension that store data using API. Well, this is not mentioned before, but we are using this because we have a really custom logic to track relationships through the time. Well, mainly is using the API from U4J to store, create nodes and relationships. Another thing, once the customer access to our platform and request a transaction, we are using this a screening application, and this screening application gets data using Traversal API and applying the different criteria depending on the type of transaction screening we are running and returning the results. This is the graph I showed you before. Is related to this extension. Finally, for our agents, the fraud agents, access to the platform to tag the different customers. We understand this is not it doesn't require performance or real-time response, and well, there is not that much stress in here. So we went for a simple, easy use case where we can use the Vault driver using Cypher queries to update this database. Yes, this is our database at the moment. We are using about 45 gigas size with 360 million of relationships and about 30 million of devices, and still it performs really well. So, well, that's all from my side. And
yeah. So we still have some time. Let's take a look at in case there are any questions.
Yeah, thank you, Alex. So a reminder to everybody, if you do questions, just go ahead and type those into the questions box on your GoToWebinar control panel. Okay, so we have one here. So if your system flags two accounts as duplicates and thus blocks the transaction thinking that it's fraudulent, is it possible to go back and remove that duplicate flag if, say, the customer shows proof that they're a different person and it's not actually fraud? How would you go in and kind of change that or mark it?
Absolutely. How it works is, of course, if the customer manages to verify that he or she is actually a different person than the one that the system automatically detected, we're able to untag as fraudulent that verified customer.
It's part of the fraud manager we are using, and the criteria for running the screening implements these conditions. It's like implementing exceptions because sometimes it's not much accurate, but well, we identify that after a while in case this is a need, and identify the need and go for it.
We've done some improvements there, but to be honest, the false positives were not too many.
Yeah.
Okay, great. And what was kind of the investment spent to build this type of a working model? So in terms of hours or money?
Well, the impact, and here we have a previous solution that it was working more or less fine for us, but we have chance to start delivering this product step by step in different iterations. We spent like 6-7 months collecting data, improving our system until we were sure or feel comfortable to enable it and disable the previous one. And that it was just the beginning. After it, we started adding more and more features, and well, it went really well. But the important thing here was analyzing the data and understanding the distribution of the data on prod, because that was the unknown for us. We did a lot of performance testing, but then when we went to prod, one of the cases that we saw is this dense node issue. Yeah, about 7 months, more or less, I guess. Yeah, more or less.
Okay, great. And is this distributed or is it just on one machine right now?
Yeah, we have a cluster of 3 nodes. And then on top of it, for running these sensitive queries, we have an application that can be auto-scaled. But at the moment, I think there are 3 nodes. It's more than enough for retrieving results and applying the screening criteria to say allow or disallow this transaction.
Okay, and I think we have time for one more. So have you had any issues with particularly large data sets or scaling your graph?
We found an issue that was a known issue, but it was related to increasing the memory of this cluster. But again, we asked for support, and in a few hours we have it working again. Yeah.
Okay, so you're still able to handle kind of large amounts of data in one graph then?
Yep.
Okay, great. So I think that we're out of time, but thank you very much to both of you from the workshop for presenting your use case, and thank you very much to everybody for joining us today, and enjoy the rest of your day.
Thank you. It's been our pleasure.
Yeah, thank you.